Okay, so I'm going to discuss with you, I don't know if you know what periodic trends are, but looking at my notes, I'm pretty sure that you had to have learned about this, and we are actually in AP Chem kind of learning about this right now. So, and I will tell you this, I'm going to try to get a lot of my homework done tonight so I can help you. It's just like, I totally forgot. I do have a lot of homework, but I always stay up late anyway, so if you have any questions, I'm going to be up anyway because I have to do my problem set. I have a lot to do. So if you have any questions, just feel free to message me because all I want to do is help you. Because I just really want to help you. I'm not here just to get hours. I really want to help somebody understand the concept. Okay, so basically, I'm going to write it over here. So the characteristics across a periodic table include the atomic radius. You also have metallic character. My handwriting just gets bad on here. You have your ionization energy. I'm just going to write E. And you have your electronegativity. That's a negative, by the way. I'm going to write neg. I'm just going to write neg because, that would look like a neg. Alright, so basically, we're going to go back over here and I'm going to explain to you what everything is. So for the atomic radius, I'm going to do red. So the atomic radius, I'm going to do increases for every one. But you have to know the arrows for each one. And this is kind of hard because I have to interpret because in my notes it says increases down a group and decreases across a period. But the way I did it was I just took increases, and then if you're trying to find the decrease, you just flip-flop it. So know which way the arrows are pointing for either decreasing or increasing. I'm going to do increasing. And then so then you don't get mixed up. Be like, oh, that's increasing, but this arrow is decreasing, because then that's confusing. So just think of them all as increasing. So the atomic radius, I'm going to do in red. So the atomic radius increases down a group. Alright? And it increases going this way. Because it says it decreases across a period, but when it says that, it means going this way. So, oops, I almost clicked clear all. So these arrows are both increasing. So I'm going to write those down. So if it goes down or it goes that way, it's increasing. Alright? Alright, so the next one I'm going to do in blue, which is the metallic character. And this one's kind of easier because, you know that these are your metals and that over here are your non-metals with oxygen and nitrogen. So this one's pretty easy because, as you can tell, the metallic character increases also down a group, but decreases across a period. But one second, because that makes absolutely no sense to me. Because, wait, I think I just got it mixed up. I'm so dumb. So, sorry, let me erase that. Sorry, I just totally confused myself. So yeah, these are metals, and these are non-metals. So, as you go this way, you are increasing it. So basically, same thing. Alright, now we're going to do yellow for ionization energy. So ionization energy, ionization energy is basically the amount of energy that it takes to take off an electron from an element's orbitals. So basically, let's do one. You know, like the electron configuration, like 1s2, 2s2, 2p1. Let's do boron. So boron has 1, 2, boron. 1, 2, and it has 1 here. Well, you're going to take the electron that is outside, which is the easiest. But it takes way more energy to get one of these electrons out. So that's what it means. That's what the ionization energy means. Just the amount of energy it takes to take an electron. Oops. Went too far. Alright, there you go. So we're doing ionization energy. So it increases up a period, and it increases across a period. Alright? Electronegativity, same exact thing. Increases there, and increases there. As you can tell, because this is the electronegativity chart. That was the only periodic table. So basically the thing is, realize that by looking at this chart, the atomic radius and the metallic character increase both ways. They are the same way. So if you know one, then obviously you know the other if you know that it is the same, if it increases the same exact way. The ionization energy and the electronegativity, same exact thing. Just know your periodic trends. Look up on the internet. Look up, there's a bunch. I think I actually have a picture in here somewhere. I don't know where it is. I might have deleted it. I'm so dumb. But like looking at all this stuff like makes me want to go back because I just think it's so pretty. But I don't think you've learned out of Avogadro's number, so I think that's a little too far for you right now. So yeah. Ugh, that's too far. Okay. So let's move on. Sorry, I didn't finish that, but you get it. I just did it. Well, let's just do it. Yep, okay. So same for both of them. So alright. So let's look up some more stuff. So here we go. This is what I have been wanting for so long. I have been wanting to read all about this. Alright. So we're going to figure out what these are. NaCl, CO2, and Au. We're going to figure out what type of bond these are. And I'm going to explain it to you because my notes say it perfectly. God, so dumb, those websites. Alright. So as you can see, if you look at your periodic table, Na is a cation. It's a plus. It's actually a +1. Cl is an anion. It's a -1. As you can tell, because there's no subscripts here. Just saying. Just a little review there. So, a metal and a non-metal equals what type of bond? Ionic. So know this. So a metal and a non-metal is an ionic bond. Here we have a non-metal, C, carbon, and oxygen, a non-metal. So a non-metal plus a non-metal is covalent. This is key right here. This is money. Know this. You have to know this because it will definitely be on your test one way or another. Au, which is what? Gold, is one type of a metal, which is just a metallic bond. It's just one metal, which is a metallic bond when it bonds with another one, like Fe. If it were to bond with Fe, it would make a metallic bond. All right, let's see. So, what is bonding? Bonding is let me type it out. Bonding, electrical attraction between valence electrons of different atoms. Sorry, it's kind of like all over the place. I can't decide where to move it. Oh my god, that's so cool. I can put stuff. What the heck? Didn't know that. So that's what bonding is, and sorry that's all the way over there. I just can't fix it. So that's what bonding is. So bond types, there's different bond types based on the electronegativity difference. No bond types based on electroneg difference. That is what bond types are based on. So, what are the different bond types? You have ionic, covalent, and metallic. So, I don't know if this is going to be on your test, but this was one of the key things that we had to know. Ionic bonding is between many atoms, and it forms a crystal lattice, like salt and ACl. Crystal lattice is like it's like a crystal lattice. So just know that it's between many atoms. So ionic, many. Covalent, between two atoms. Metallic, many atoms many atoms from same element.